afternoon, students. So welcome to Mr. Chen's master class. So today I would like to talk about the next sections, 4.7. So this one is the exact same sections as 7.4 from that James Stewart textbook. Okay, so it's about the inverse trigonometric functions. So given the graph of y equals r sine of x is the same as inverse of sine of x, and the graph of y equals sine of x. So state a domain in the range of sine inverse. Okay, so let's find out. So this one, so basically that tells you the graph. So for the domain here, so you can see that it's from negative pi over 2 to pi over 2. Okay, so they're both included. And then for the range, so the range would be considered negative 1 to 1. Okay, so negative 1 to 1. Okay. This one is just for the sine curve. Okay. Now, what about the inverse? So the inverse, that means you want to swap the xy value. So for the domain right here, it's actually from negative 1 to 1. Okay. Include it. And then for the range, so this one, it's called the restricted range. We're going to be using that for finding the inverses. So restricted range of inverse of sine, or r sine, it's from negative pi over 2 all the way to pi over 2. And for those you might be wondering, well, how come they're being switched? Well, because at this one, they consider inverses of each other. So try to make the line of symmetry going through. So the line of symmetry, so let's say y equals x. So you'll see that, so this one, the graph here, they're kind of symmetrical with the line of symmetry. Okay, so now let's find out the rest of those exact values. So evaluate inverse of sine of root 3 over 2. So one thing that we notice, root 3 over 2, so sine of theta equals root 3 over 2, that means it's considered 60 degree, or pi over 3. Okay, so what this one is saying, that sine of theta, so equals root 3 over 2. So what angle makes that sine of theta equals root 3 over 2? So which is what? 60 degrees. Or pi over 3. And then what about r sine of 3 pi over 4? So r sine of 3 pi over 4, well, sine of 3 pi over 4, so this one, it's a little bit weird. So you might be wondering, r sine, because this one's supposed to be the ratio, but sine and r sine, this one basically even things out, so that's just the angle itself. So that one is just like 3 pi over 4. Okay, so it's right here in quadrant 2. And then r sine of 5, we don't know what that is. So r sine of 5, well, is that possible to have a ratio greater than 1? So according to the range, inverse restricted range, so the ratio of the range here, of the domain, it cannot be anything less than negative 1, or it cannot be anything greater than 1. So there's no such thing involved with this. So this one, no solution. And what about r sine of 11 pi over 6? So a lot of people might be wondering, wait a minute, isn't that just 11 pi over 6? Because that r sine and sine just got cancelled. Well, for sine, r sine, they can be cancelled. But for this one, cannot. Because sine of 11 pi over 6, it's considered sine of pi over 6 in quadrant 2. So sine of pi over 6 in quadrant 2, it's not in quadrant 2. So this one is actually in quadrant 4. So it's like sine of pi over 6 in quadrant 4, which is negative 1/2. And then according to that, the restricted domain, so inverse of sine of negative 1/2, which is over here. So then that would be considered pi over 6. Okay, so negative pi over 6. Okay, so check that. So this one, you cannot just simply cancel out that r sine, okay, and sine. And now this one, for what values of x is that r sine of x equals x? Well, this one again, if you take that r sine, so that means you'll be coming up with that angle. So that angle must be right in between negative pi over 2 and pi over 2. It's all depending on the value of x. So this one is just finding the restricted range of that r sine of that function right here. Okay, so r sine of the function. So this one, so the x value should be bounded right between negative pi over 2 to pi over 2. And then sine of r sine of x. So again, r sine of x, this one will give you the range of negative pi over 2 to pi over 2. So sine of negative pi over 2 to pi over 2. So that means once you cancel this out, so it's all about the value of x. We're just finding the ratio. So this one is being bounded from negative 1 to 1. Okay, so it's being bounded from negative 1 to 1. And then let's see what else. So give the graph of f of x equals r cosine of x, inverse of cosine of x, and then g of x, the parent graph of cosine of x. So it looks like this one is just half of a cycle of cosine of x. Again, if you just draw the line of symmetry, y equals x, you'll see that they're symmetrical to each other. So state the domain, the range of the cosine inverse. Okay, so state domain range of inverse of cosine. So this one, as you can see that the domain here, it's from negative this one is showing that it's from negative pi over 3 to pi over 3. Okay, so it used to be the arc cosine. The domain, it's always from, well, for this graph, it's actually from negative pi over 3 to pi over 3. But the actual domain for the inverse of cosine, we'll talk about that in a minute. So range, so the range here is actually from 0 to 3. Okay, from 0 to 3. So this one is kind of weird. It's just like shifting the inverse graph. But normally, the restricted domain for the inverse of cosine is actually from 0 to pi. And then the restricted range. Okay, excuse me, the other way around, actually. So for the domain here, yeah, that's right. It's from 0 to pi for the domain. No, somehow the graph here is being shifted. It's just being transformed out a little bit differently. Okay, so regardless what happened with this graph, number 2. So this one, there's some kind of typo going on. Okay, so you try to state the domain to range, that's right. But normally, for the given inverse cosine function, so the restricted domain, it's actually from negative 1 to 1. Okay, from negative 1 to 1. Oh, you know what? Because this one, yeah, it is. It is correct. So we just swap that, the xy value. Okay, so got to be careful with the way to state that the domain to range for this. Because we're making a graph on the same xy coordinates, the same xy coordinate plane. So for the domain here, so this one can just say that it's from negative 1 all the way to 1. But for the range is actually from 0 to pi. So this position right here, it's right a little bit higher than 3. So it's 3.14. Okay, like that. Evaluate the following. So using that, the restricted range. So inverse of cosine of 1. So we do know that the restricted range of inverse of cosine. So cosine is just like what, from 0 to pi. And then 1 is over here. 1 comma 0. And the other side here is negative 1 comma 0. So 1. So obviously the radian, it's always considered 0. So in other words, this one is saying that what angle makes cosine of theta equals 1. So that angle with the restricted range. So theta equals 0. And then here's another one. So inverse of cosine of negative 1/2. So again, restricted range of inverse of cosine is from 0 to pi. So the ratio is showing that it's negative 1/2, so that means it's in quadrant 2. So negative 1 and then 2. So reference angle right here. So this one is considered pi over 3, so 60 degree. So pi over 3, it's in the quadrant 2, so reference angle. So subtract from pi, so that means theta equals pi minus pi over 3, which is considered 2 pi over 3. And then arc cosine of pi over 8, and then cosine of that. So again, arc cosine of pi over 8. So this one is written as cosine of theta equals pi over 8. And then cosine of that angle. Well, this one, the angle would be considered unknown. Okay, so we don't know what that is. But pi over 8, that's just the ratio. It's in the first quadrant. So that means this one is just like going back to the first quadrant. So that would be the exact same ratio, pi over 8. So that one is a little bit tricky. So sketch the inverse of tangent of x. So inverse of tangent of x. So that means we just want to swap that VA. So with pi over 2, so that would be the horizontal asymptote. And then negative pi over 2, that would be the horizontal asymptote also. So normally at pi over 4, then we do have what? 1. And now we just swap that xy value. So 1. And then comma pi over 4. Okay, so 1 comma pi over 4. And then over here, so also similar. So in negative pi over 4, so we do have negative 1 down here. So this one pi over 4. Okay, so 1 pi over 4. So basically it's 0, so that's 0. Inverse of 0, tangent of 0, it's just 0. So basically connect the dots. So it's a sideway cubic curve. Again, it just make the line of symmetry, y equals x. So you see that it shows the line of symmetry. Okay? And then our tangent of infinity. So if x goes to infinity, so y is getting closer and closer to what? Pi over 2. So it's kind of like finding the end behavior. And then our tangent of root 3. So in other words, like tangent of theta equals root 3 over 1. And then we do know that restricted range of inverse of tangent is from negative pi over 2 to pi over 2. So it's a positive ratio, so that means it's in quadrant 1. Opposite over adjacent. So root 3 over 1. So that means this angle here, it's considered pi over 3, 60 degree. Okay, so pi over 3. And then our sine of 5 over 12. So this one, it can be always written as theta. So it's just like tangent of theta with that triangle. So restricted range of sine is from negative pi over 2 to pi over 2. So it's a positive ratio, so that means the triangle, it's allocated in quadrant 1. So sine, so opposite over hypotenuse. And then for the adjacent, so we don't know what that is, using the Pythagorean theorem. So 144, root 144 minus 25. So then that'd be 1 square root of 119. Okay, so let's check that. And we don't know what that number is, square root of 119. So but the tangent of theta, so using that the same triangle. So what we found, tangent of theta, so then that would be considered 5 over root 119. So 5 root 119 over 119. And then the rest of this, quite similar. So our tangent of 2x. So this one, let's set up the ratios, just like 2x over 1. So again, this one is just like finding secant of theta. So that's 2x over 1. So again, positive because x is greater than 0. So it's a positive ratio. So it's in quadrant 1. So opposite over adjacent. So 2x over 1. Hypotenuse, we don't know what that is, but we can use the special right triangle. I mean the Pythagorean theorem. So then that would be considered square root of 1 plus 4x squared. So secant of theta, so r over x. So square root of 1 plus 4x squared all over 1. Or just that square root of 1 plus 4x squared. And the other one, r cosine of 1 over x. X is less than 0, so that means this ratio, it's negative. So negative for cosine, so restricted range is from 0 to pi. So negative ratio, so that means this one is in quadrant 2 with that theta. And then r cosine is 1 over x, so that means it's adjacent over hypotenuse. Okay, so this one, and then make sure that this hypotenuse is going to be positive x. But somehow that x is saying that's negative, so we shift the negative sign to its negative 1. So saying that this one is sine of theta. So sine of theta here, again, opposite is missing using the Pythagorean theorem. So we do have square root of x squared minus 1. So sine of theta is square root of x squared minus 1. And it's all over x. But gotta be careful, hypotenuse, it's always being positive. So let's say that it's positive, absolute value of x. Okay, so this one, it gotta be very careful. Okay, so it's a little bit tricky there. Why do we need to put the absolute value? Because that's considered a radius. So for number 5, a balloon rises from point C and create the angles of elevation theta. Okay, so here's the balloon. Elevation. So looking up, theta. So rise up from point C and create the angles of elevation theta. So measure from the ground at point A. So point C is actually right here. And then point A, it's off the ground, perpendicular to the base. The distance from A to C is 100 meters. Okay, so find theta in terms of the height h. So this one basically just using tangent. So tangent of theta, so that would be h over 100. So find theta, so theta equals inverse of tangent of h over 100. Okay, so it's pretty straightforward. So solve each equation by hand. A unit circle will be provided. Give an answer to the nearest 10. Okay, so point 3. Well, if the unit circle is provided, we can measure it, but this one, since you have to round it, so just do it on the graphing calculator. So basically just take the inverse of ratios of 0.3 with the radian, so find out what theta is. And then for B, so this one is 0.2, it's run between 180 and 360. So now, got to be careful with the restricted range. So for the first one, the restricted range for the inverse of sine is from negative 90 to positive 90. Okay, so that means, so theta, it's in quadrant 1. So inverse of sine of 0.3. Okay, so inverse, second, inverse of sine of 0.3. Again, it's a positive ratio, so it's run between negative pi over 2 to pi over 2. So right here, so the angle is about 0.304 or 0.305. Let's see. We have to round it to the nearest 10, so it's 0.3 radian. And then for B, so similar. So take the inverse of cosine of 0.62 and see what theta is. And this one, theta, it must be running between 180 and 360. Okay, so it's 180 minus 360. Okay, so take the inverse of cosine of 0.62. Okay, so inverse of cosine of 0.62. So second inverse of cosine of 0.62. And then you'll find out the ratio, which is positive 0.902. But 0.902, where is that at? Is that in quadrant 2? So try to convert that to degree, because you want to find out exactly what that is. Multiply by 180, then divided by pi. So that angle is actually considered acute. So the acute angle, the one that you found, is actually the reference angle. So the reference angle that you found, it's 0.902. Or 0.9. Again, this one is just the reference angle. Since we do know that theta, it's right in between 180 and 360. So it's a positive ratio. So that means the angle is going to be in quadrant 4. So 2 pi minus 0.9. Or this one can be done by what? 360 degree minus 52, 51.7. Minus 51.7. So subtract, so we do have 308.3 degrees. Because the ratio is showing that it's positive, and the boundary, the restricted range, is from 180 to 360. So that means the angle, it's allocated in quadrant 4. So the one that we found here on the calculator, that's just the acute angle, which is the reference angle. So subtract from 2 pi to get the measure of theta. So this one, you don't want to include that as theta, just the reference angle. So for part C right here, just think about it. So inverse of tangent of negative 0.25. So take the inverse of tangent, negative 0.25. So this one is being bounded from negative pi over 2 to pi over 2. So basically, just follow through the standard restricted range of inverse of tangent. So tangent of negative 0.25. So second inverse of tangent of negative 0.25. Okay, let's find out what that is. So you might be wondering, it's a negative radian because that's going by clockwise. So this one, yeah, so which is correct. So that would be theta. So it's negative 0.2 rounded to the nearest 10. So negative 0.2. Convert that to degree. Okay, so multiply by 180 over pi. So multiply this number by 180 over pi. So multiply by 180 divided by pi. So what we got here, it's what? Negative 14 degrees. Okay, so negative 14 degrees. Or you want to round it to the nearest 10, so negative 14.0. Alright, so now what about for the rest of this? For what values of x are cosine of x defined? Okay, so in order to have that defined, so cosine of x, we do know that the range is right between negative 1 to 1. So for what values of x? Okay, so this one is one of the interesting one. So the ratio here for cosine of x, it's always considered either right between negative, it's either negative 1 or 1. So bounded right between. Again, it's all about the matter of the range. So inverse of cosine of negative 1, so then that would give you pi. And then inverse of cosine of 1, then that will give you 0. Okay? So once you find the angle, but the thing is that this one is asking about x. Can we plug in any number for x? Negative, positive, there's no restrictions. And it looks like this one here is showing that x, but once you take the arc cosine of the ratio, so it's always being bounded from 0 to pi. So if this one goes from 0 to pi, so cosine of 0, this one is one of the interesting one. So let's put it this way. So values of x for that arc cosine. So it doesn't matter what kind of x value that you put in here, so that the ratio could be 0, positive, negative, and we do know that x, there's no restriction. So if there's no restriction, this one basically we can put in negative infinity to infinity. But what about the range for that arc cosine of x? It's the same kind of expression, but this one, it does matter. So the restriction for this one, in order to get that angle, okay, so the angle is always being bounded from 0 to pi. From 0 to pi. Restricted range. So domain, it doesn't matter. Okay, so for the domain, it doesn't really matter. You can put in any number. But for the range here, so once you take the inverse of cosine of any kind of ratio, positive, negative, small number, big number, so this one, the range is always from 0 to pi. Okay, so now what about arc cotangent? So what's the necessary transformation to convert that arc tangent to arc cotangent of x? Okay, so one thing that we noticed, so tangent of x is considered cotangent of 1 over x. So in order to convert that arc tangent to cotangent of x, so all you need to do, so simply just take that, the arc cotangent of 1 over x. Okay, so just convert out the ratio to its reciprocal. So what values of arc cotangent of negative root 3 over 3? So in other words, this one is just like arc tangent of, well, we do know that tangent and cotangent, they're both considered odd functions. Okay. So this one also, they're kind of symmetricals. So negative root 3 over 3. So check that. So negative root 3 over 3 for theta. So it looks like that part right there, there's no solution because one is the inverse of tangent, the other one is arc cotangent. Okay, so it looks like this one, there's no solutions found it. Okay, because arc tangent of, okay, so negative root 3 over 3, it's over here somewhere. And see that they never got intersect. Oh, wait a minute. No, this one we're not setting equal to each other. Yeah, we can find a solution. So arc cotangent. Okay, so arc cotangent of negative root 3 over 3, then that'd be this angle all the way up here. So this one, which is the same as the ratios of arc tangent of, if you try to convert that to arc tangent, then that'd be kind of weird. Okay, so just leave it as the normal way, perhaps. So the one that we have is the domain, and then we just want to find out the position of the angle. Okay, so find the value. So this one, let's just convert that to its negative. So it's arc tangent of 1 over root 3. Well, that would be the same ratio. So then that would be arc tangent of negative root 3. So arc tangent of negative root 3. So inverse restricted range of tangent is from negative pi over 2 to pi over 2. So this one's going to be right here in quadrant 4. So definitely it's going to be a negative radian. Okay, so this one is considered negative root 3. This one is 1. And this one is 2. So going this way, so the angle here then that would be considered negative 60 degree or negative pi over 3. So negative pi over 3. Okay, so which is the one right here, negative pi over 3. But if you're looking at that for this one here, the range, it's actually all the way up here. So negative pi over 3 reflected over. And for that one, it would be considered two pi over 3. If you try to use the graph, then that would be considered, the different solution. So r cotangent of negative root 3 over 3. So negative root 3 over 3. For the r tangent, it's actually negative pi over 3. So the one that we found. But for the other one here, for the cotangent one, it's actually all the way up here. So that one would be considered 2 pi over 3. So just use the graph. Okay, so that one's a little bit tough. If you try to find out the transformations, well, for the positive, we can do that. We can take the reciprocal, like this one right here. But for the other part right here, if x is less than 0, so you don't just want to come up with that, the inverse, the reciprocal. Okay, so this one, r cotangent of 1 over x is for x, which is greater than or equals to the point right here. Okay, so this one just reflected. Over the reciprocal. So pi over 4, so this point right here. So up to this part. Yeah, just putting down the restrictions. There's no need putting the restriction. Just keep it that way. Alright, so it's all about the transformation. And also regarding that the inverse of tangent and cotangent. Okay. So just keep that in mind, the restrictions, the restricted range of sine and cosine. So restriction of sine is always, so this one is always from negative pi over 2 to pi over 2. And then restricted range of cosine, it's always from 0 to pi. And then restricted range of inverse of tangent. So this one's from negative pi over 2 to pi over 2. And then what about for cotangent? So cotangent, the restricted range. So this one, you want to put in from 0 to pi. Just like the graph that we did right here. Restricted range of cotangent. See that from 0 to pi. And then what about for secant? So restricted range is from 0 to pi over 2. And then from pi over 2 all the way to pi. Okay, so got to be careful with that secant because that would be the horizontal asymptote at pi over 2. And then for the restricted range of cosecant, so this one is just the reciprocals of sine, so it's like from negative pi over 2 to positive pi over 2. Okay? Yeah, that's it. So thank you for watching the video today. So I'll see you guys next time. Take care.